Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. Today we're going to be testing out the microscope and the soldering station from Xtronics. We're going to solder some tiny little components. We have the soldering iron. I have this little tip on here. I'll show it to you in the microscope in a minute. I got my microscope set up. I got my soldering station in the corner here. I'm going to turn on my iron. And first I'm going to turn on the soldering station in the back. There we go. Then I'm going to turn on my iron. And it's set at 350. I can live with that. It's gonna power up there. I got some super thin solder here. Okay, so that's just about there. I'm going to take it, I'm going to tune it up here. Trying the sponge technique and see how that works. So, not a fan of the sponge. Going back to my little thing here. I like that better. So I'm going to put that away. I'm going to move this over here. I'm going to bring down my microscope so I can get to it. And I'm going to put on the microscope. And we have a resistor. Here's the different components here. This is some SOP 23s. We have some ICs, an SO14, SO16. And we have some Zener diodes, and then we have a strip of resistors. So we're going to go to R1 here first. I'm going to do a bunch of different things with this. So I'm going to get me a resistor out. Now I could sit this resistor down there like this, and I could, attempt to solder it on there, but what I'm going to do is I'm going to pre-tin the pads with a little bit of solder. So I hope I got the right size soldering tip on there. Pre-tin the pads a little bit. Pre-tin the pad. And then I'm going to set this on there. Like that. I'm going to attempt to reflow that side. Probably wouldn't hurt to add some flux before I do this. I'll do that with the next one. So that doesn't look too bad. So let's get it over here. So it's not too bad. Could be a little cleaner. So what I can do is I can add some flux and reflow that. And I'm going to be doing some different techniques and stuff to just add a little bit of flux and reflow it. Looks better. So there we go. That is the first test. I'm going to use some hot tweezers to make sure that's on there. Yeah, it's not moving. just a little dirty from the flux. But we can clean that up with some, well, actually I have some flux remover. So just clean that up with my flux remover. You could use IPA for this, but go, nice and clean. Looks good. Nice shiny joints with that. Now, I did not do that with the fume extractor on for the sole fact that I wanted to see what it sounds like, because I'm having issues with sound again because of all the things running in the background. So this time I'm going to do it with the fume extractor on. I'm going to see if that is disturbing to the video, so just bear with it. You might need a different type of mic, but you need the fume extraction. Okay, so let's get a resistor. To it. Let's clean that up with the flux remover. And that looks good. Just check it out handle here. Yeah, it's actually sticking up a little bit on that side. Yeah, I see it. So I'm gonna do this. More solder on there. Focus that in there. Okay, that's all soldered in there. They're both soldered in. So I'm going to shut down the fume extractor, and then I am going to play this video back and see how bad the sound was. So, still gonna post it though. Be back. Okay guys, I am back with some more soldering action on this video. I know I had the fume extractor on in the last segment and it was super loud for the mic, and I think I need a headset mic, and I don't have the funds for that currently, so we're just gonna have to go make do with this. I moved the fume extractor as far away from the microphone as I could, so we're just gonna have to make do during the soldering parts of the video, which happens to be this whole video. So I put on some parts yesterday with the soldering iron using the end-on microscope. I put on that one. I have it tilted for angled view. I like it better than straight up and down, so you see it better. So we're going to put on another component, but this time we're going to use hot air, and I thought I was better with the hot air station than I actually am. So we're gonna do this. We're gonna turn on our soldering iron, and we're gonna turn on our hot air. I'm gonna put my airflow at 3 out of 9, whatever that means. And it's pretty cool because it doesn't turn on until you pick it up, and then it turns on. So first thing I want to do is I want to tin these pads with my soldering iron. That's up to temperature. Let's get this on there, and let's get you better into focus there. So we're going to tin these 2 little pads up here, and the fume extractor needs to be on. And remove this whole thing here. I know that fume extractor's loud. I'm sorry, guys. Like I said, I'm going to get a headset mic and I got 2 solder blobs on there. Alright, so I'm going to get my flux. And I don't know, I use this stuff right here, this Chip Quick SMD 291. I really like it. I got some stuff from Northridge Fix and Amtech or whatever it is, and I haven't tried it yet. But I'm going to try it soon. I like this Chip Quick. It's like tacky, so it works in my book. And this is a weird holder with the magnets, but it does work for what I'm doing now. I haven't tried it for an actual repair or something. We're just, getting some of my skills down and some practicing, testing out the new equipment. That. Okay, hopefully that'll sit in position. I'm going to grab my hot air and I'm going to knock some stuff around. It's going to get hot, as you can see there. And then we're going to come in here. And it's going to move out of the way. It's going to flow in there just like so. And there we go. So, resistor in there, and then I'll put my thing down and it will cool down and shut back off and be ready to use it again. So that's the hot air station. It works. Not a bad joint. Could just touch it up, add a little flux and touch it up. I'm messing with trouble doing this. I'm gonna have to turn it this way so I can get I should have left it the way it was with the hot air. So I'm still getting used to working under the microscope because I want to look down at it, but then I have to look at the screen. So I'm still, getting used to it. But that's the hot air. We can turn that off. We're not going to need that. So let me slide this back and let's go over a few other things here. I'll turn the gun off, or the iron off. Let's go back to this overhead, and we will take off the webcam. Alright, so let's take a look at a couple things here. Let's move the iron. Let's take a look at what I have set up for the testing in-circuit components. So I have this here. This is I did an unboxing. I think it was an unboxing of 3 things for these tweezers, and they work pretty great. Let's see if I can come down here. Come this way. Okay, here's what they look like. A little bit. So, if you need to test a component in circuit, these work great. So I have this board here that I'm working on. I got the ports soldered back on. Okay, that's done. I can turn that off. So I got the port soldered back on here. That's soldered back on. I just got to reconnect the battery and whatnot. But I just want to demonstrate this meter here on some of these capacitors. So let's turn it on and let's see if it does its auto thing here. And it tells me that is, now that is well, it doesn't stay on there. So that is the 24. So 187, and see it goes to 109 micro. See, because these two are in parallel, so I need to change the settings. So I believe it's 1, 2, no, not that one. It's 1, 2, 3. There's parallel. So let's check it now. So that's 110 micro. One next to it. One's 620. No, now it's 110. I think I slid over and touched the other one. So now we're getting a resistance. So 111. So I want to check something here. I want to just check it as a resistor and see what the ESR is. So it's 20, well, 100 megohms. It changes as it charges up with the 1K frequency. This one is 20, megohms. So this is megohms. I still have it input on. Okay, I don't understand. Okay, 1, 2, 3. Okay, 1, 2. Okay, let's check this now. Is it in auto? Yeah, so getting a little bit. Yeah, so all these. So if you got if you're checking capacitors, none of that was on screen. I'm sorry, guys. If you're checking capacitors for dead shorts, you come in here. And you just grab it and you can measure the ESR if you can get a hold of it, and megohms, so it's not a shorted capacitor. So you can also measure inductors, you can measure resistors in line. I can show you that on this board right here. That's going to be 360K, because that's what these resistors are. So you can measure, stuff like that. It's, it's going to be a good diagnostic tool. for the projects we have coming up, which I will discuss more about. I will be discussing a project coming up in more detail when it arrives. It still hasn't shipped yet, even though it's already been paid for. So that is irritating in its own right. So that is going to do it for the soldering demo. Oh, you know what? We didn't test out the hot tweezers. So we are going to come back under the microscope to this resistor right there, and we are going to hot tweezer these. So we're going to get out the hot tweezers. Let me show you the hot tweezers. So here are the hot tweezers. Zoom back out, wrong way. Here are the hot tweezers. Boom, 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 boom. They're in their own little holder here. And then it has a power supply that we will turn on, and it's set to 352C. That's fine with me. And then we will go to the microscope view, and I will just tin these a little bit. Alright, let's see if we can't come in here and remove that component, and let's see if we can put it back. And we put it back. So did not use the fume extractor, that was my bad. Whew. But see, the hot tweezers, good to go. This is not a high-end version of hot tweezers. These cost about $60 on Amazon, but they will serve my purpose. I'm not working on iPhones or anything, so, but we'll talk more about that in the future. Thank you so much for watching. Check out the social media links. Support me on Patreon. Thank you so much, and have a fantastic